everybody. This video is going to talk about adding and subtracting polynomials. So this is part of chapter 6. So there's a couple things you need to know before we start actually adding and subtracting polynomials. When we do this, we're going to think about it as combining like terms. So when we solved equations at the beginning of the year, we said like terms means that it's the same variable and the same exponent. So a lot of times we would combine our x's together. But if we had multiple variables, like I couldn't combine an x and a y together. So some examples of like terms would be things like x squared and negative 3x squared. Those would be considered like terms because they have the same variable, x, and the same exponent of 2. Okay, another example would be y and 4y. Again, we have the same variable y, and in this case, they both have the same exponent of 1. So we would be able to combine those together. Okay, examples of non-like terms would be things that are different variables, such as x and y. I wouldn't be able to combine those together because they're not the same variable. And another example would be something like x and x squared. Even though they have the same variable, this x has an exponent of 1 and the other has an exponent of 2. So because they don't have the same exponents, they're not considered like terms. They cannot be combined together. So here's what it looks like when we add and subtract. We have 3 different terms here, and you're going to hear me use the word term a lot. Each one of these is considered a term, okay? We have addition between all of them. We need to find which ones can be combined together, and when we combine them, we're going to add the coefficients together, but the variable and the exponent will remain the same. Okay, so what I notice is this one has an m to the 3rd power. This has another m to the 3rd power. So those two should be able to be combined together. Now when we do this, we're going to take the 15 and the 2. Okay, that's what combines to make 17. However, it keeps the m to the 3rd power. We don't do anything with the exponent of the variable. We are combining by only adding together the coefficients. The variable and the exponent remain the same. Now, this leaves us with a 6m squared here. That doesn't combine with anything, so we can't forget about it. We have to make sure we copy it back down for our final simplified answer here. Okay, so this is a polynomial expression, and a lot of times what we'll do is we will name our polynomial expressions based on the number of terms that they have. So I'll give you a quick list off to the side here if you want to jot this down on your notes. Depending on the number of terms, we have a name that we'll give it. If there is a single term, it is called a monomial. If there are 2 terms, like we have here, it's called a binomial. If we have 3 terms, we call it a trinomial. And if we have, here's the L here, if we have 4 or more, we're going to call it just a polynomial. Now, if you know some of your roots, like for words, it's a little easier to remember. Okay, mono means 1, bi is 2, tri is 3, poly means many. So that can help you memorize which of those is which. So in this case, we had 1, 2 terms, so this would be considered a binomial. All right, so let's look at another example here. So again, we have 3 terms, and we need to figure out which ones can be combined by finding which terms have the same variables with the same exponents. So here we have a 2s squared plus a 3s squared. So those combine to make 5s squared. Remember, our variable and exponent stay the same. And then we just have this plus s left over. Remember, I can't combine s and s squared together because even though they're the same variable, they have different exponents. Okay? So again, we're left with two terms. This would be a binomial. Okay, but I want to add something on here. We can also name polynomials based on the number. Let me start over there. Based on the biggest exponent. So the number of the biggest exponent here would be 2. Now, this has a special name. This is what we would call the degree of the polynomial. The biggest exponent in your polynomial expression is called the degree. So we can give a name for this polynomial based on its number of terms, which we've already done. We can also give it a name based on its degree. So I have another list for you. If the degree is 0, that means my biggest exponent is 0. I would just have a number. It would be like a polynomial that's just the number 5 or something like that. If I have a degree of 0, we would call it a constant polynomial because it's just a single number, a constant number. If the degree is 1, meaning my biggest exponent is 1, we would call it a linear polynomial. Okay, you guys have learned about linear functions this year. So you know that the biggest exponent for those is 1. Okay, y equals mx to the first power plus b. If our degree is 2, it's quadratic. If the degree is 3, it's cubic. 4 is quartic. And 5 would be quintic. If I have anything higher than that, what we would do is, this is really just going on and on forever. So we would say that for any degree n past 5, it's just going to be called an nth degree polynomial. Okay? So this is just a naming system. So our degree for our polynomial expression here was 2. So that means that this is a quadratic binomial. Okay, it's just a little more specific. Okay, adding some detail, it makes it easier to talk about what kind of polynomial we have. We have a quadratic binomial. All right, so I want you to pause the video at this point, and I want you to try numbers 3 and 4. Okay, so for number 3, we can combine our x squareds together. Notice, though, that this is a minus sign. So when I'm doing this combination here, 3x squared minus 7x squared, I have to actually subtract to get a negative 4x squared. We also have a plus 5 and plus 12. So those can combine together. Those are just numbers. And that would make a plus 17. So there is our simplified expression. So let's name it. Our degree is 2. And we have 2 terms. So if the degree is 2, just like the last one, we said it's quadratic. If it's 2 terms, we said it's a binomial. For number 4, we have some more terms this time. Okay, we start off with 5 terms. I have some z to the 4th powers that can combine. Okay, they're being added together, so we would get 20 z to the 4th power. I have some z's that can combine. This is a negative 8 plus 2z, so that would give us negative 6z. And then I have this plus 3 that's left at the end. Okay, so this time we have something different. We have a degree of 4, which means it's quartic. And we have 3 terms, which means that this is a trinomial. So there we go. Now, technically, we have been adding monomials together at this point. We have one monomial, two monomials, three monomials, four monomials, and five monomials. Each one of those terms is called a monomial because it's just the product of numbers, variables. It's a variable by itself, or it's a number by itself. Those are all monomials. They're single terms. If I am adding or subtracting polynomials, this looks slightly different because typically each polynomial will be grouped in a set of parentheses. So in this case, this would be one polynomial. Technically, it's a binomial because there's two terms. And this would be another polynomial. Now notice, I am adding these two polynomials together. Okay, well, if it's addition, I don't need these parentheses here. If I want to add these polynomials together, that's the same as getting rid of my parentheses, and it looks just like the problems that we did. We have a bunch of terms, we need to find our like terms, combine them, and that's it. So we would have a 2x squared plus x squared. So remember, this is a 1 here, so we get 3x. We have some x's that can combine, so negative 1x plus 3x would be plus 2x. And we have our constant at the end, minus 1. The degree is 2. We have 3 terms, so this is a quadratic trinomial. So here's another addition one. I want you to pause the video and I want you to try it. Okay, so remember with addition, okay, with these two polynomials, if it's addition, I don't have to write these parentheses. So I'm going to rewrite it without the parentheses. And you don't have to do this. If you can see what needs to be done without rewriting it, that's fine. Okay, and this one is a little trickier because we have b's by themselves, we have an a by itself, and then we have this combination of a, b. So these are going to be like terms because they both have a, b being multiplied together, both to the same power of 1. So a to the first power, b to the first power for each of these terms. So we are able to combine these together even though there's multiple variables. So if it's negative 2 plus 2, I get 0ab, which is going to cancel these terms out. That leaves us with b plus a. All right, now subtraction makes it a little trickier here. Once you subtraction, you can't just get rid of the parentheses and combine things together. Okay? We know that anytime we have a minus sign in front of a set of parentheses, we need to distribute, just like we did when we were solving equations. So that still applies. So this part, I don't need to write the parentheses anymore. That part doesn't have the negative distributed to it. Only what comes after the minus sign will have the minus sign distributed to it. So we would distribute the negative to the 4x squared. We would distribute it to the negative 2. And now it becomes just like our previous problems. I can combine my like terms, and we'll be done. All right, one more. So the last one here, another subtraction. I want you to pause the video and I want you to try this. Okay, so again, with subtraction, we can't just get rid of the parentheses. We need to distribute the negative to everything that comes after it. So doing that, we would end up with a to the 4th minus 2a minus 3a to the 4th plus 3a minus 1. I can combine my a to the 4th powers. So I would get negative 2a to the 4th. I can combine the a's together to get a plus a, and I'm left with a minus 1 at the end. All right, so that is it for this video. Feel free to pause, rewatch, rewind, and please ask questions. Have a great day.